Okay, Shanmukh, okay. Okay, hello everyone. Welcome to the first session in the series of Oracle Database Server Architecture. Basically, we are going to have a number of sessions wherein we will discuss each and every component that is involved in case of Oracle Database Server. Now, when we talk about, say, the term architecture, basically we are speaking about, say, a layout or a design. Okay, if we have to take a simple example, then it could be the architecture of a house. Okay, let's say if I want to build a house, I'll hire a professional architect, and with the help of architect, we will prepare a layout or the design which is at this moment only it's in my mind, right? But to be able to build it, we need to have a proper design of the components which are going to form the house. Okay, so that we refer to as architecture in general terms. So taking continuing with the same example, if I'm going to build a house, I'll have to exactly mention to the architecture how I want the house to look from outside, what would be the number of bedrooms in the house, what should be the size of those bedrooms, then say the placement of the wardrobes inside the bedrooms. If you are going to need a kitchen in the house, right? So inside the kitchen you will have to tell him what would be the size of fridge that you are going to buy in the new house. Okay, then you will decide what would be the location or say the placement of sink in the kitchen, the number of shelves, height and width of the shelves, so on and so forth. Next, it could be, say, the garage, the number of garages that you need. So based on the family requirement, it could be one car or two cars. And while you are going to design the layout of the garage in that architecture, it will be designed keeping in mind the size of the cars. It may be a small car, and another one it could be a bigger car. So the size of the garages also will have to depend on the size of the cars. So similarly, if we carry forward the same example to Oracle database server, in this diagram or say the architecture diagram, you get to see a number of components. Okay, and in these sessions, basically we will be discussing
Bro,
how exactly, sorry,
can you share your screen?
I haven't shared my
No,
screen yet.
no, you haven't shared.
No, 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 bro.
Okay, okay, sorry. Yeah. Okay. Yeah. Now, is it visible?
Yes, yes, yes.
Yes, it is.
Yeah. Okay. Yeah. Thanks for pointing that out. Okay. So if you see this slide, basically this outlines the whole Oracle database server architecture. Okay. So what I was saying, in case of Oracle database server architecture, you are going to see a number of components. Okay, and what we need to understand is what is the functionality of each and every component, how these components are related to each other, how they are dependent on each other. Okay, so all of these things we will discuss under the Oracle database server architecture. Now, one question that anyone should ask at this point is why we need to be aware about the architecture of this Oracle database server. Okay, so the primary reason for that is if you are going to be working as an Oracle DBA, you have to know what are the components of it, right? You have to know that how those components are going to behave, because in scenarios when you are stuck in, and if you have got some or the other problems to resolve related to Oracle database, you have to know the architecture of the environment or the software you are going to be working on. And the more clear you are with the flow of the architecture regarding the components, the better DBA you will be. Okay, that is my understanding of all these years of experience as an Oracle DBA. Okay, so this is how the Oracle database server architecture looks like on a paper. Okay, now we will come back to this diagram. First, we will discuss another very simple diagram and try to get an overview of the architecture. So basically what happens with Oracle database server is it has got two components. The architecture has got two components. Okay. First one is called the instance, which is also known as the memory component that you see over here. And the other part is the Oracle database, which is also called as the physical component. Okay, so in layman terms, if we have to define the Oracle database server architecture, it basically involves two components. One of them is a memory component and another one is a physical component. Okay, now why exactly do we call this component named as the instance as the memory component? Okay, so basically this part of the architecture is going to reside inside the server memory, that is inside the server RAM. And as we know, the RAM is basically the memory part of the server. Okay, that's why the oracles in case of Oracle's architecture, this component named as instance, because this is going to reside inside the server's memory, we call it as the memory component of the architecture. Whereas this component that you see, which is called as the database, why exactly is it called a physical component? Because it is going to hold some of the files, or it is going to occupy some space on the disks. Okay, now those disks, basically it can be local to the server or it can be a shared set of disks. Now when we say shared set of disks, it means that it may be those disks may be shared across multiple servers. Okay, so because this component, it is actually present on your database, or say it is actually present on the storage disks, which is a physical component in the server architecture. Normal architecture also, if we talk about, the storage disks are physical part, right? So that's why the Oracle database, which is going to be present on the storage disks, we call it as the physical component of the architecture. Okay, so architecture has got two components. The memory component is named as the instance and the physical component is known as the database. Are we clear with that?
Yes, bro.
Look, okay, fine. Now let's move to the actual architecture diagram. So first we will start with the memory part of the component, which is the Oracle instance. Okay, now in case of Oracle, what happens is the instance is, you can think of the instance as a door to the database. Okay, now why do we call it as a door to the database? Because any user, if you see this placeholder over here, any user or any application that wants to connect to the database, in case of Oracle, they don't actually directly connect to the database. Okay, they always connect to the instance. Okay, so to the end user or to the application users, they may think that they are connected to the database. They may say that they are connected to the database, but they are not actually connected to the database. They are connected to the Oracle instance. Okay, so that's why we call it as a door to the database. Okay, now why also another reason behind it being called as a door to the database is, like I mentioned previously, this instance is going to be present inside the server memory. Okay. And we know that if this, we know that the memory basically it is not a permanent storage area. Anything that is running inside the memory or the RAM, it is not a permanent area, permanent storage area. Okay. So if for some reasons your server goes down, okay, or if for some reason your server becomes inaccessible, okay, in that case, we are saying that this instance that is running or that is present inside the memory of that server is actually not available. Okay. So if the instance is not available, that means the users cannot connect to the database. Okay. So that's why we say that unless and until this instance is available, the users can't connect to the database or they can't do their intended tasks. Okay. So if the instance is not available, it is as good as the door is shut. Okay, you don't have access to the door, right? So that's why we use that terminology of the instance being as the door to the database. Okay, are we clear with that, Deepak?
Yeah, yeah, Dhruv.
Okay, thanks. Okay, so that is about the instance. Okay, so now coming to the physical part of the architecture. Okay, at this moment we are only briefly discussing or briefly understanding these components. Okay, we will discuss it everything in much more detail now. Okay, so coming to the database or say the physical part of the architecture here, if you see, database basically it is consisting of a set of files. Okay, those files you will be able to see on the storage disks. Okay, if you do a listing of the files present inside a directory, you will be able to see them. Okay, so these file types that you see over here, control files, data files, and redo log files, they are the primary component of the physical architecture, that is your database. Okay, so there, why exactly have I drawn it like this? Okay, because there can be multiple control files, there
Yeah.
can be multiple data files, and there can be multiple redo log files. Okay, and
Okay.
these are the mandatory file structures that you will be seeing inside the database. Okay, that's why there are two separate boxes over here. Okay, this this other box, all the components that you see, they are also file types only. Okay, but they are optional file types. Okay, your database can function without them. Okay, so these are just some of those file types like archive logs, flashback logs, trace files. There are going to be backup files and so on and so forth, other kinds of files as well. And these file types are actually going to be present on the storage disks. That's where your all your data is going to be stored. Okay, clear with that?
Okay, Dhruv.
Yeah, okay. So now, if we discuss more about this database server architecture, you also see some of the placeholders like this user process, listener, and server process. Okay. Now, what are those? Why exactly they are being represented in this architecture diagram? Let's try to understand that. Okay. But let's take an example. Say that there is this user who wants to connect to the database. Okay, he has some tasks to do. Okay, so if I have to take a simple example, let's say that you need to buy some certain things from amazon.in. Okay, so as soon as you start the Chrome application or any of those web browsers, or say if you are doing it from your mobile, you start the Amazon app. Okay. So as soon as the user who wants to connect to the database, he starts an application, a browser, or some kind of software to connect to the database, something called as a user process gets created on his system. Okay. So a user process is basically a client side process. Remember that a user process is actually a client side process. It will always get created on the user system. Fine. Now,
Yes.
if the user wants to connect to the database, or say if you are going to order something from Amazon, you need to have a user ID, right? You need to have a proper login credentials. So taking the same example to a database, if you want to connect to a database, basically you will need a valid credentials, right? Now, those credentials will be provided to you by the DBA. Okay. How exactly we create the users, what are the password complexities that we can have. Password complexity is very simple thing that we all get to see whenever we create a user and it asks for a password. We all are aware about it, right? It will ask for some special character. There has to be one number, all that stuff. Okay. So that is creating the users, maintaining the passwords, all that are tasks of a DBA. Okay. So coming back to continuing with the same example, the user, he needs to have a valid credentials to be able to connect to the database. Okay. But just having the valid credentials is not enough in case of Oracle. Okay. Because in this architecture, you also get to see this process called as listener. Okay. So listener is basically a process that will be running on the server side. Okay. It will be running on the Oracle server. Okay. And what is the task of this listener? What function does it do? What is the purpose of a listener in case of Oracle server architecture? See,
In
the
order
job of
to,
the
sorry, Dhruv,
see
to interrupt.
the job of the job of the listener process basically is to accept the incoming connection requests. Okay. Now, similar to this user, there are going to be n number of such users who wants to connect to this database. Okay. So to accept the connection request for all those users, on the server side, Oracle has given us this process by the name listener. Looking at the name itself, you will be able to understand the name. It is assigned a name as listener. So basically, it listens for the incoming connection requests. Okay. Its task is to accept the connection request for all the users who wants to connect to the database. Okay. Now, if we want to understand more in detail about the listener, let's take the example of a receptionist in an office. Okay. Now, what is the job of a receptionist? She accepts the connection, she accepts the calls, right? And then she will pass those calls to the intended people. Okay. So if she receives a call and someone wants to speak to, say, Mr. X, she will route that call to Mr. X. Okay. If someone wants to talk to, say, a person Y, she will route the call to the person Y. Okay. So that's the job of the listener. Now, why exactly did I take that example of a receptionist? Because the listener process also, it can accept the connection request for multiple databases. Okay. Like the receptionist is accepting the request for all the people who are working in that office. Similarly, there can be multiple databases running on a server. Okay. And there can be only one listener process who is accepting the connection request for, or it is listening for the connection request for all those databases running on that server. Okay. So in simple terms, it is acting as a middleman. It is only going to be running on the server side. It will see this user, which database he wants to connect to. Okay, let's connect that user to this database. There is another user who wants to connect to some other database running on that server. So what this listener process will do for that user, the listener process will connect it to the other intended database. Okay, so that's the job of the listener. Now, couple of things that we need to remember about the listener is that one listener can accept the connection request for multiple databases. Okay, multiple listeners running on the same server can accept connection request for the same database as well. Okay, so both way it is possible. Are we clear with that?
Yes, Dhruv, yeah.
Okay. Okay, so the next thing that we see here is something called as a server process. Now, what exactly is a server process? So similar to the listener, this is also going to serve some purpose. That's why it is existing. Now, what happens is this listener process, basically when it receives the connection request, it will create a server process on the server. Okay, so the listener as well as the server process are server side processes. They will be running on the server side. Okay, now why exactly the listener process will create the server process? Okay, so the server process, its responsibility is to go and verify the user credentials. Okay, whatever credentials that the user has provided to the listener, okay, those credentials, whether they are valid or not, it has to be checked, right? To only allow authenticated or the correct users into the database, their credentials has to be validated at the time of connection. So that is the job of the server process. Okay, so the server process will validate the connection requests. Okay, so that is the first primary purpose of the server process. Okay, the server process, once it has verified that the user is a valid user, okay, what it does is it will create something called as a PGA. Okay, now what is a PGA? PGA is something called as a program global area. Okay, or it, in simple terms, you can also call it as a private area. Okay, the full form would be program global area, but in layman terms, we also called it as a private area. Now, if you see at this architecture diagram, there are two such PGAs that you see inside the instance. That is because for every user who is going to be connected to the database, okay, every user who is going to be connected to the database, you will get to see a dedicated server process for that user. Okay, so for every user process, there will be a dedicated server process and a dedicated PGA as well. Okay, so the idea behind me representing two PGAs over here is that I wanted to show that there will be multiple PGAs existing inside the instance, okay? And each of the PGA is representing a successful connection to the database. Getting that?
Dhruv, like, is it for every particular user, one PGA will be getting created? Is it?
Yeah, that's right. For every successful connection to the database, there will be a dedicated PGA assigned for that user, for that session, sorry. Okay, now
Okay.
what exactly is a session? Basically, when we say that a user has been successfully authenticated in the database, okay, we say that his session is established. He is connected to the database. That means a session is established. Okay, that connection can be called as a session. Okay, so
Okay.
there will be multiple PGAs present inside the instance, okay, and each of the PGA will be representing each of the session that is connected to the database. Okay. Now those PGAs are belonging to a dedicated session. Each of those PGAs are belonging to a dedicated session. That is not a shared area. Okay. Now if I am connecting to the database, there will be a PGA for me. If Deepak is connecting to the database, there will be a PGA for his session as well. Both these PGAs are going to be present inside the instance. Okay. But they are dedicated to my PGA was dedicated to my session. Deepak's PGA was dedicated to Deepak's session. The information, whatever is present inside my PGA, cannot be accessed by Deepak's PGA. Okay. They are completely independent of each other. Okay. So make a note of that thing. That's why it is also called as a private area. Okay. Now inside the PGA, we then see further components. Okay. Further subcomponents. Something called as a UGA, which is also called as user global area. Then if we move inside the UGA, you get to see something called as a private SQL area, SQL work area, session memory, and a couple of more components. Okay. Now again, all these components are basically going to serve some purpose. So let's discuss about those as well. Okay. So inside this UGA, the first component that you see is something called as a runtime area. Okay. Now what exactly is a runtime area? Let's take a simple example in case of a user who is connected to the database. Okay. He fires a command wherein he wants to see all the cities present in India. Okay. Now the result set, okay, it may happen that it is taking some time to return the result set to the user. Okay. So what is the current state of execution of that specific query? Okay. Let's say that you want to see the list of all the students in the class. Okay. So when a user has fired a query to see see all the students that are present in the class, okay, when that query is executing in the database, we call that the whatever is the state of execution of that query, that will be present inside the information about that will be present inside the runtime area. Okay. The next is the persistent area. Okay. Now what is a persistent area? What happens in case of Oracle server is, say in case of Oracle is, or rather Oracle SQL, we make use of something called as a bind variable. Okay. Now what is a bind variable? If we have to take a simple example, a bind variable is basically something for which you can pass the value at runtime of a query. Now this is again getting a bit technical in terms of SQL part. Okay, let me try to write a query. Okay. Now let's say that I want to find the list of all the employees who are reporting to the manager who has employee ID as 1. Okay. So one way to run the or one way to write this query would be like this. Okay. Where manager, say manager underscore ID, the column name would be like manager underscore ID. Okay, so one of the way to write this query would be like select employees from EMP table where manager ID is equals to 1. Okay, the other way it could be that we make use of something called as a bind variable. It is like a placeholder. So the difference between the execution of this query, it will be that